I hope you're having as much fun as I am. We are on problem number 71 in Physics GRE GR1777. Consider the polyspin matrices sigma x, sigma y, and sigma z. The product sigma x, sigma y is equal to which of the following? So by definition, polyspin matrices are a set of three 2x2 complex matrices which are Hermitian and unitary. So our polyspin matrices are going to be sigma x equals this, sigma y equals this, sigma z equals this. So sigma x, sigma y is going to equal, and let's do our matrix multiplication, which I've given a little cheat sheet above. So AE, BG, this is how we do matrix multiplication. That's the top left. Top right is AF times BH. Bottom left is CE, DG, and bottom right is CF times DH. Looks very complicated and messy, but let's see what it works out to. It's really not hard once you get the hang of it. So sigma x, sigma y on the polyspin matrices. This is going to be based on our matrix multiplication that we just went through above. 0 plus I, top left, 0 plus 0, top right, 0 plus 0, bottom left, minus I plus 0, bottom right, and that simplifies to I, 0, 0, comma I, and this is not A, B, or C, as we can see from the polyspin matrices that we have right here. So let's test out D and E. So sigma y, sigma x is going to equal 0 minus I in the top left, 0 plus 0 in the top right, 0 plus 0 in the bottom left, I plus 0 in the bottom right. And this is actually the negative of what we want. As you can see, this is what we're going for. And so if you just multiply this by -1, this is actually answer E. Number 72, the binding energy per nucleon is greatest for which of the following nuclei? Iron has the highest binding energy per nucleon, and it's at the center of massive stars also. So here is a graph that gives you the binding energy per nucleon, and it is indeed iron, and that is answer C. Number 73, the negative muon has properties most similar to which of the following? The electron, muon, and tau are all identical except regarding their mass. So, of course, the answer is E. It is identical besides the mass to the electron. Answer E. 74. Which of the following correctly gives the quark and antiquark content of a lepton and a baryon? So, leptons have no quarks. Baryons, like the proton and neutron, have 3 quarks. And just for the record, mesons have 1 quark and 1 antiquark. So, if we are counting quarks, then the answer is for lepton 0 quarks, 0 antiquarks. Baryon 3 quarks, 0 antiquarks. Answer A. Number 75. Under certain conditions, a beam of electrons impinging on a crystal surface will diffract and a scattering pattern of the beam can be obtained. What is the approximate kinetic energy of the electrons needed in order to see the pattern? Assume the lattice spacing of the crystal to be 0.4 nanometers. So from Bragg's law, we know that 2d sine theta equals m lambda, and d and lambda must be roughly equal. So the de Broglie wavelength, lambda, equals h over p, where p then can equal h over lambda. P is the momentum. So p squared over 2m we know equals the energy, and that equals, therefore, h squared over divided by the quantity 2m lambda squared, where we have E equals 6.2 times 10 to the 18 electron volts per joule, that's our conversion factor, times 6.6 times 10 to the minus 34, that quantity squared, divided by the quantity 2 times 9.1 times 10 to the minus 31 kilograms, that's the mass of the electron, times 4 times 10 to the minus 10, quantity squared. And we need to remember that 1 nanometer, refer back to your cover sheet, where we have our conversions. 1 nanometer equals 10 to the negative 9 meters. And as you saw, we converted from joules to electron volts. So 1 joule equals 6 times 10 to the 18 electron volts. And so our energy is going to equal 2.7 times 10 to the negative 48 divided by 2.9 times 10 to the negative 49 equals about 10 electron volts. and that is answer C. 76. A beam of positive ions is initially moving in the positive x direction with non-relativistic velocity. The beam enters a velocity selector in which the electric field E is oriented along the positive y direction and the magnetic field B is oriented along the positive z direction as shown above. Which of the following gives the critical speed Vc at which the ion beam is not deflected as it moves through the velocity selector? So when the particle is undeflected, QVC, which is the critical velocity, times B equals QE, where Q is the charge, B is the magnetic field, E is the electric field. So critical velocity just simply equals E over B, and that is answer E. 77. Under ideal conditions, the electric and magnetic fields inside a superconductor are zero. Maxwell's equations imply that which of the following must be true outside the surface of the superconductor? So I've included a picture. This is going to give us a really good visual representation. Thank you, Wikipedia, for providing this picture. So the critical temperature is what the problem is referring to as ideal conditions. Below this temperature, superconductors have complete ejection of magnetic field lines from their interior. This is the Meissner effect. From the diagram, you can see that the field lines are tangent to the surface in superconductors that are below their critical temperature, and so that is answer C. '78. A positive charge plus Q oscillates up and down as represented in the figure above. What is the direction of the pointing vector S at point P? Assume P is located far to the right of positive Q. So the pointing vector represents a directional energy flux, which is the energy transfer per unit area per unit time of the electromagnetic field. So S, the pointing vector, is going to equal 1 over U times E times B, E cross B. So the oscillating charge radiates energy radially, which is dependent on R, the distance from the charge. So a point to the right will feel energy flux moving towards the right. So that is simply answer B. '79. A block with mass M1 that slides on a frictionless table is attached by a massless string over a massless frictionless pulley to a hanging ball with mass M2 as shown in the figure above. The tension in this string must be, so we can say we know that M2G minus M2A equals the tension. If the block was hanging stationary, then M2A would equal 0 and M2G would equal the tension. But the block is sliding, so M2A is greater than 0, and therefore M2G minus M2A we know equals the tension. So M2G has got to be greater than the tension since M2A is greater than 0. And so that is answer C. Number 80. Two planets of mass M revolve around a star of mass big M in a circle of radius r as shown in the figure above. The two planets are always on opposite sides of the star. The orbital period t of the planets is of the form t equals 2 pi square root of r cubed over gm prime. What is the value of m prime? So m prime is going to be our center of mass. So each smaller mass feels a gravitational pull from the big center mass, big M, and the other smaller mass, little m, that is opposite of it, and they are always this way. Therefore, the force from the center of mass, F of C equals G big M little m over r squared plus G little m times little m divided by quantity 2r squared. So the center of mass force is going to equal G big M little m divided by r squared plus G little m times little m divided by 4r squared. So F center of mass is going to equal G little m divided by r squared times the quantity big M plus little m divided by 4 when you do the algebra. So therefore the center of mass m prime is m plus big M plus little m divided by 4. And that is answer D. Okay, we're getting close. I'll see you in the next set of 10.